Got this in pocket. Got that though. I'm gonna use it. Intention of feeling mental. Gonna make you notice.
Okay, we're going to finish section 8.1 today on sine, cosine, and tangent. And as always, it's for right triangles. Okay, that's always the case that sine, cosine, and tangent, you must have a right triangle. And we do have a right triangle. This big triangle here is a right triangle. Okay, I want you to assume or pretend for a second that this angle down here, let's say that this angle right here is about 45 degrees. I think it is around 45 degrees, but let's just pretend it is 45 degrees. Okay, if you were to go to a calculator and ask it what is tan 45, so I'm going to put tan 45 in here, you will get, I've picked this angle because this is a very kind of special one. Tan 45 is 1. Tan 45 equals 1. Now, what does that mean exactly? I'm going to write it down here. Tan 45 degrees equals 1. Well, basically what that means is the ratio, because remember these are ratios, sine, cosine, and tangent are ratios. The tan ratio, and what is the tan ratio? Remember, I'll write down SOHCAHTOA for you so you can remember. What does this tan ratio refer to? The tan ratio is opposite over adjacent. So the ratio of the opposite side, the length of the opposite side, I guess I should say, divided by the length of the adjacent side is equal to 1. Now, do we know exactly how big each one of these sides is? No, we don't. It could be 1 and 1, couldn't it? Because then opposite divided by adjacent, 1 divided by 1 would be 1. But it doesn't have to be 1. What else could it be? How about 23 and 23? 23 divided by 23 is 1. So that would also work. So you notice it doesn't matter how big or how small the triangle is. We talked about this last time. If it's a 45-degree angle and it's a right triangle, if you look at the opposite side and the adjacent side, it will always equal 1. This could be maybe this is a very small triangle right here and it's only 0.5 centimeters over here and 0.5 centimeters here, and that is a 45-degree angle. Or maybe this is 16 kilometers long. It's a huge triangle and 16 kilometers long here. Then this would be 45 degrees there. Okay, it's always the same. What if we had another triangle here? Let's say we had another triangle here, and this side over here was 11 centimeters. And this side over here was 11 centimeters. Well, you should be able, from what we've already said, you should already be able to tell me that this angle here is 45 degrees, right? Because opposite over adjacent is 1, and we know from up here that that means it's 45 degrees. But let's pretend we didn't know that. Let's pretend that you're only given this information. It's a right triangle, and these two sides are 11 centimeters by 11 centimeters, and we want to know this angle right here, and I will call that angle, or designate that angle with the theta sign. Often that's what we do with an unknown angle. So I want to know this angle right here. How do I do that? Well, the first thing I do is I look from that angle. I want to know what these sides are in relation to that angle. So if I look from that angle, what's this side? Well, it's across from that angle. This is opposite. And what's this angle? This is right next to, it's adjacent to the angle. This one, we're actually not interested in this question, are we? It's not going to help us figure out that angle because we don't know that side, so we'll just leave it blank. But you know that's the hypotenuse, don't you? Alright, so now what we do is we ask ourselves which one of the ratios, sine, cos, or tan, uses opposite over adjacent, or opposite and adjacent. So we look up here, opposite hypotenuse, adjacent hypotenuse, opposite adjacent. There it is, tan. Tan equals opposite over adjacent. So I write tan. Now I write down the angle, but I don't know the angle. So what do I write? I write tan theta. That's the unknown. I don't know the angle. Equals opposite. How much is opposite? 11. Over adjacent. How much is adjacent? 11. So tan theta equals 11 over 11. We could simplify that. 11 over 11 is the same as 1. So I want to know for which angle is it that if I take tan of that angle, I get 1. Now again, we know the answer is 45, but I just want to show you how you would do this if you didn't know the answer was 45. What you do is you take inverse tan. And the way that works is, so what we do is we want to know what the angle is, and the angle is equal to tan negative 1 of 1. Tan negative 1 means inverse tan. So tan to the negative 1 equals inverse tan. Or another name there is for inverse tan, you won't see this very often, but I'll write it down. You see it in university for some reason. University, they don't seem to call it inverse tan, they call it arctan. So those are all the same thing. Okay, so you have to get inverse tan of 1. So we're going to need our calculator for that. Now, how do we do that in our calculator? What you do on your calculator is one of the following things. On your calculator, you are either going to put inverse tan, to put this tan negative 1, you're either going to first hit a button that's usually on the left top of your button. It says second on it, and then after that, you'll hit the tan button. Or instead of having that second button, you might have a button that says inverse, or often INV, inverse, and then you'll hit the tan button. Or you might have a button that says shift, and then you'd hit the tan button. Or, this is unlikely, but I think on the calculator I'm going to show you, you might have a button that just says inverse tan, tan negative 1, in which case you don't have to push one button. Usually, all of these buttons, this button here, and this button here, they'll usually be a different color, so they show up better on your calculator. Not always, but often that's the case. So this is what we want to figure out. Let's go to my calculator, and we want to figure out what's inverse tan of 1. So I go to my calculator, and I'm looking for a shift, and you can see on my calculator, it's very nice. It has the inverse tan button right there. So all I have to do is hit inverse tan. You see that it says ATAN? That's like arctan. Remember I said that inverse tan was the same as arctan? So arctan or inverse tan of 1 equals, and I better get 45 degrees. If you don't get 45 degrees, the reason is you either inputted it wrong or because your calculator isn't on degrees. Remember, it must be on degrees, not in radians. So I have just determined that the inverse tan is 45 degrees. So I can say that the angle is 45 degrees, and that's what we expected. Okay? Alright, that's basically what we're going to be doing today, using that inverse tan, shift tan, whatever it is on your calculator. So if I tell you the ratio, the sine ratio is 0.883, that's what the ratio is, and I want to know what the angle is, how do I do that? I do the inverse. Here's a little memory thing. I know this is absolutely ridiculous, but it might help you. When you think of me, your teacher, Mr. Wadge, what are the first two words that come to mind? Go ahead. What are the first two words? I'm sure the two words you thought of were fit and hot, right? Come on, admit it. Why is that going to help you remember this? Because if you are finding the angle, then you need to put inverse tan or sine or cos. If you have the angle, then you only hit tan or sine or cos. Okay? So in this case, do we have the angle? No. We're finding the angle in this question, aren't we? So we're going to have to put inverse tan. So the angle equals inverse sine of 0.883. That's how we find our angle. So we go to our calculator, we put inverse sine of 0.883. Clear inverse sine, you'll probably have to put shift or second or whatever, sine of 0.883, and that will give you an answer of 62.006. Let's just call it 62 degrees. So this first question is 62 degrees. Okay, next one. Cosine theta equals 0.990. Do we have the angle or are we finding the angle? We're finding the angle, so we have to use the fit, not the hot, I'm afraid. Fit, we're going to use the inverse tan, or in this case, inverse cos, of course. Okay, so the angle is equal to inverse cos, or arc cos if you want, of 0.990. So we go to our calculator and put inverse cos of 0.990. Again, you probably don't actually have this button that says inverse cos. You'll have to put shift cos or second cos or inverse cos. And when I do that, I get 8.1096. Let's just call it 8.1. We'll go to 1 decimal place. So 8.1 degrees is our answer here. Okay, the next one, tan theta equals 14 over 23. These were decimals. This is a fraction. Seems a little bit harder. Guess what the first step can be? Just change it into a decimal. How do you do that? Divide 14 divided by 23. So we'll start by doing that, 14 divided by 23, and you will get 0.6087. Okay, I'm going to write all that down. I want to be very exact here. 0.6087. Now I can do the same thing we've done up here. If I want to know what the angle is, I'm trying to find the angle, so I'm going to do inverse tan, or arctan, 0.6087. So we go over here to our calculator and hit inverse tan of 0.6087, and we get 31.3. 31.3 degrees is our answer. Don't forget to put degrees on this. We're finding an angle, so you should have a degree sign on these answers because they are angles. One thing, if you could also do this in one step, it'll actually give you a more exact answer. If I wanted to know what the inverse, if I wanted to know what this angle is right here, I could also take the inverse tan. The angle is equal to the inverse tan of 14 over 23. You might have to use brackets, but it's pretty easy, it's faster, and it gives you a more accurate answer. So let's see if I could do that. Inverse tan of 14 divided by 23, throw that in brackets, hit equals. Look at that, it's just a tiny bit different than the answer we had before. This second answer is actually a little bit better. Why? Because this 0.6087 is a rounded off answer. This one isn't as rounded off, so it's a better answer. So it's faster to do it that way. Makes sense to do it that way. Why not always do it that way? Okay, just one last question. We're going to solve this triangle. Remember, when we solve the triangle, we need to get all the angles and all the sides. So we have three things this time. We have two sides and one angle. Last class we did two angles and one side. This time we have two sides and one angle. What do we still need to find? We need to find this angle up here. We need to find this angle up here, and we need to find this side here. Put a little highlight there. We need to find this side here. What's the name of that side? It's B, isn't it? Because it's across from the B. Now, I don't like how they name this. I wish they'd name this C, because usually we call the hypotenuse C, but it doesn't really make a difference. It may seem a little confusing in our first step, because why don't we figure out this hypotenuse right away? How could we do that when we already know two sides? We could use the Pythagorean theorem. Now, usually we write the Pythagorean theorem a squared plus b squared equals c squared, but the hypotenuse in this case is b, so it makes it a little bit confusing. B squared equals a squared plus c squared. I know that seems a little confusing because that's not the way we usually write the Pythagorean theorem, but hey, all we've done is called the hypotenuse b instead of c. It's not a huge deal. Okay, hopefully you're following what I'm talking about. A squared, well, a is 8, so this is 8 squared. C squared, well, that's 5 squared. So b squared equals 64 plus 25. So b squared equals 89. So how do you get b? Take the square root of 89. And if you do that, I won't do it on the calculator. I'll just tell you the answer to that. The answer to that is 9.43. And it says mi here. What's that? That's miles. 9.43 miles. Wow, that's one big triangle. So this b right here is 9.43 miles. Okay, we still have to get the angles. Pick an angle. You can pick either one. Doesn't matter. You could pick A and figure out what angle A is right now. You could pick C and figure out what angle C is right now. Let's do C. I don't know why. I just want to. So we're going to find this angle up here. Okay? So you can do this in many different ways. In fact, since you have all the sides, you could use any of the ratios. You could do tan C. You could do sine C. You could do cos C. Let's do all of them and we'll show you it doesn't matter. What's tan C equal? Well, tan's opposite over adjacent. Opposite, 5 over adjacent, 8. Tan C is 5 over 8. What's sine C? Opposite, 5 over hypotenuse, 9.43. What's cos C? Adjacent, 8 over hypotenuse, 9.43. Alright, so if tan C equals 5 over 8, then C, angle C, we're finding the angle, so we have to use inverse tan of 5 over 8. If we were doing this one, C would equal inverse sine of 5 over 9.43. If we were doing this one, C would equal inverse cos of 8 over 9.43. Alright, well let's do the first one. Inverse tan of 5 over 8. So we go to our calculator. Inverse tan of 5 over 8, 5 divided by 8, equals 32.00, basically 32. So we'll put that down, 32 degrees. Should we check another one and make sure it works? Why not? Inverse sine of 5 over 9.33. Inverse sine of 5 over, or divided by, 9.43. Should be very close. It might be just a tiny bit different because that 9.43 was a rounded answer. Whoa, I did something wrong. What did I do wrong? See that? I didn't put arc sine or inverse sine. I just hit sine. So I should have put inverse sine equals 5 divided by 9.43 equals 32.02. Very, very close. Just a tiny bit different. So again, 32 degrees. And the last one is inverse cos equals 8 divided by 9.43. So inverse cos equals 8 divided by 9.43. And that equals, should be very close, 31.9667, which rounds to 32. Again, the reason these ones are a little bit different is because this 9.43 is a rounded answer. But they all round to 32 degrees, don't they? So C equals 32 degrees, C equals 32 degrees. Do you have to do all these? No, you only have to do one of them. Pick any one you like and do one of them. So I'll just circle one of them here to show you we've done that one. This is 32 degrees up here. We still have to get one more angle. What would be the fastest way to get that other angle? Hint, we already know two angles. Hey, if we already know two angles in a triangle, we can get the third one really quick because they always add up to 180. So angle A is equal to 180 minus the 90 degrees minus the 32 we just found. So angle A is equal to 58 degrees. Let's just test that. Remember I said that we could have started, before we got angle C, we could have found angle A? How could we have done that? Let's find angle A. And again, with angle A, you could do it any way you wanted, sine, cosine, or tan. Let's do tan. So just to make sure it still work, tan A, of course it will still work, but I just want to prove it to you. Tan A. Tan is opposite over adjacent. What's opposite from A? Opposite is 8. Remember, if we run out of that corner. 8. Adjacent is 5. So tan A equals 8 over 5. So to get angle A, we need to do inverse tan of 8 over 5. Sure hope we get the answer 58 degrees. Let's see. Inverse tan of 8 divided by 5 equals 57.99. I think it's safe to round that to 58 degrees. So just like last time, you can see there's all sorts of different ways that you could answer these questions. There's not one way. The person beside you might be doing different steps than you, and you can still get the right answer. You didn't need to even use Pythagorean. If you hate Pythagorean, find these angles first, the two angles, and then you could use one of the ratios, sine, cosine, or tan, to find this side by using the sort of stuff that we did last day's class. Okay, that's it. Hope it's making sense. If not, come and see me.
Gonna use my arms, gonna use my legs, gonna use my style, gonna use my side step, gonna use my fingers, gonna use my imagination, 'cause I gonna make you see there's nobody else here, no way.